Hi, Honors Algebra. This is 1.5, day 2, and we are on our second page of our 1.5 notes. And we're going to carry forward with our example B. And if you look here, we definitely have a compound inequality here. We actually have a combination of two inequality signs in the same statement. That actually means that this is an and statement. So anytime you see two inequality signs without an actual word in there, and or nor, it's really implied to be and. Because what we're saying is that 7 is less than 4x plus 5, and also 4x plus 5 is less than or equal to 21. So that word and is inherently coming out in that statement. So because it's an and, we're going to treat it as such. So when we finalize our answer, we're going to look to see where they actually overlap, where the graphs overlap and the solutions do. So in this case, notice where our variable is in the middle, because I have a left side of the inequality sign, I have a right side of the inequality sign, and the variable is somewhere in the middle. So because it's in the middle, we want to isolate that variable in the middle. So to do that, we're going to get rid of the terms that are with it. So if you notice, we have a 4 being multiplied right now by x, and we have a 5 being added. And as always, you're going to perform the inverse. You're going to be performing the order of operations backwards by performing the inverse operation. So in this case, since 5 is being added, we want to subtract it. So what you're probably not used to seeing is, yes, we're going to subtract it in the middle, but we also want to subtract it from all the other sides as well. So we want to subtract it from the left side as well as the right side. So 7 minus 5 is 2, is less than 4x. The 5's canceled in the middle, which is our goal, because we're going to eventually isolate that. Is less than or equal to 21 minus 5. So 21 minus 5 is 16. And then, almost done, we're going to isolate that x now in the middle by performing the inverse operation of multiplication, which is division of 4. And again, if we're going to divide by 4 in the middle, we have to divide by 4 on either side, left and right. And as always, you need to simplify as much as you possibly can. So 2/4 reduces to 1/2, which is less than x, which is less than or equal to 4. And this works out really nice because all we have to do then is graph this solution. So if we were to make an actual graph of this problem, here's 0, here's about 1/2, and here's 4 over here. So what this says is give me all the x values that are between 1/2 and 4, also including 4. So there's a closed interval set there, between there. So all my x values between 1/2, but up to and including 4, are right there, all of those values. So that's our solution. Notice that there's a closed interval here at 4 and an open interval at 1/2. So if I had to write this in interval notation, that would be 1/2 all the way up to and including 4. And there you go. So I know it hasn't practiced in a while, so that would be interval notation, all right? So moving on to problem C. We have an or statement. So in this case, we're going to do two separate graphs here and then see where not where they overlap, because it's an or statement, so we actually want to combine them both. So I could get rid of the 3, but there's really no reason to, because it works out quite nice with less steps. If we just take 2 times negative 6x, which is negative 12x, and divide that by 3, which is negative 4x. So I'm going to distribute that 2/3 to everything. So 2 times negative 12 is negative 24. But negative 24 divided by 3 is negative 8. So what we're saying is negative 4x minus 8 is less than 2x. So we're going to go ahead and solve this inequality here. And it's up to you if you want to get the variable to the left or right. Totally up to you. I'm going to bring the smaller one over by adding 4x to both sides. So I have negative 8 is less than 6x. If I divide by 6, notice though I'm keeping the x here on the right side. I don't want to all of a sudden just put it on the left and forget about the direction of my sign. So negative 8, 6 reduces negative 4/3. But now, since I've solved for x, I'm going to go ahead and put that more comfortably on the left, but I don't want to change the meaning of that answer. So I'm going to make sure that the open mouth is still facing the x, so as not to change that actual solution. So here, x is greater than negative 4/3. And over here now, we have, I'm going to just go ahead and rewrite this equation out. Oh, there's something very interesting about this problem. So what's interesting about this problem is this negative sign is in front of this entire quantity, 2x plus 6. So you have to treat it as such. So eventually that's going to get distributed. But let's wait until we see what we can do. So actually on this side, we can go ahead and multiply everything by 3. So when we multiply everything by 3 here, we're going to get 12 is less than or equal to. Now the 3's cancel here, which is nice. But as I mentioned earlier, I have this negative sign pertaining to the whole quantity, 2x plus 6. So when I distribute that, it changes the actual numerator to negative 2x minus 6. Okay? So now if we go ahead and solve algebraically, I'm going to solve for x, so I'm going to add 6 to both sides. And I have 18 is less than or equal to negative 2x. I'm going to follow through with my x, my variable on the right side, so I don't get confused or change anything yet. Okay, so warning, when you're dividing by a negative or multiplying by a negative, I almost made that same mistake. Warning, you have to flip that the direction of that inequality sign. So we have greater than now. So I have negative 9. So if I pull this up here, if you're more comfortable with your variable being on the left, then put your variable on the left. And just don't change the meaning of it. Remember, the open mouth is still facing the negative 9, so we want to keep it that way. All right. So in this case, this is an OR problem because we were told up here that it was an OR. So if I were to graph this solution and this solution, and then I'm going to unite them because the OR tells us to unite both solutions. So I'm going to graph this top solution here first. So x is greater than negative 4/3. So negative 4/3 is somewhere right here. So everything greater than that would be going in this direction. So I'm just going to shade, sorry, open interval. And then directly below it, remember, you want to align your numbers. So negative 9 is somewhere way over here. So I could make this bigger, or I could just span it out and saying, okay, I know negative 9 is somewhere down the line. All of my values less than or equal to negative 9. Since negative 9 is included, that means I'm going to have a closed interval there. And all of my solutions less than 9 go to negative infinity. So, because it's an OR graph, I want to unite this graph with this graph on one graph. So if I were to make this my graph and unite them, this is what it would look like. It would be all values greater than negative 4/3 and all values less than or equal to negative 9. So this graph is my actual solution to this inequality. Now, you have to write your answer in interval notation. So what we're going to do is write that in interval notation. And the graph actually helps us out. Notice that our lowest number to our highest number, and we have some stops in between. So our lowest number is negative infinity, which is an open interval because you can never reach that. all the way up through and including -9, so it's a closed interval there, united with, because it's an or statement, -4/3. -4/3 is an open interval because it's not included in our graph, all the way up through infinity. But again, you cannot ever reach infinity, it's unbounded, so you have to have an open interval there. All right, so that's our solution. And that's it for the notes for 1.5 day 2, and you can go ahead and work on your homework. We will be doing one of the problems, I believe question 81, during class time. So if you have questions on that, don't worry about it. We will approach that during class time. Thanks.